for number 10, it says explain transformations of the apparent function y equals e of x. Explain the right and left shifts, expressions over y and over x in vertical stretch strength or in horizontal stretch strength. Must show in real time the steps to show the problem. So what I did is I described the e of x transformations. So 100 plus 5 is 3. So vertical stretch and strength. So 3 of e of x, that equals the stretch of a more than 1. So you just do the graphs for other examples. So 1 divided by 3 is e of x equals strength as a is less than, is more than 1. So horizontal stretch strength, all you gotta do is z cubed plus x is stretch, c 1 over 3 x is a strength, up and downs, and then also e of x plus 3 is up, and e of x minus 3 is down, right, left, and then ex minus 3 is left, ex minus 3 is right. So for these, all you gotta do is graph them. So which is pretty easy. That's what reflect over y-axis or y-axis minus e of x equals x of the axis, e equals cubed or square root of negative x equals y-axis. So all you gotta do is graph them, and that's pretty much it. You gotta graph all of these, so we can do it in the calculator on the website. So all you gotta do is go over here, go to Mathway or Desmos, and you could just say a equals 3 over e of x. It's 3 over e of x. So yeah, so you can see it's a stretch. So that's all you gotta do. You gotta graph it, and then you can see if it's a stretch or a strength. So that's 10. So for number 11, it says, how is the inverse of a function determined graphically and algebraically? Elaborate using one example. You must show in real-time steps to solve the problem, explain to solve the problem. That's for number 11. Number 11, what I did was the inverse of a function originally and algebraically. So this is a change of the shifter, so all you gotta do is, let's say the function is 2 over x plus 3, so all you gotta do is switch it, so it's 2x plus 3. So the start process, all you gotta do is x minus 3 over 2 equals 2y over 2. So it equals x minus 3 over 2 equals y, so that will be the inverse of this equation. In the graph, what you gotta do is the graph should intersect, the x should be equal. So that's all you gotta do in the graph, since you just gotta find the opposite of it. So it would be the graph should be intersect the x. So what the x was, you should intersect it, and then it should be equal. So I think that should be it for that. So for 12, it says explain how to determine if a function is even, odd, or neither. Your explanation must include the process algebraically and graphically. So that was for number 12. So number 12, what I did was, for even, you gotta do if it's symmetrical and it can be folded into f of y. So f under negative x equals odd, so you got flipped over, it's not am 12. So neither, you gotta see if it's not even or odd, since f equals x, or foot. So candidate examples. Some examples of this is, this is even, which you can see in the graph. This is the odd. So this type of graph is odd, and then this type of graph is neither. So a function that you can use to see this is x cubed minus x plus 1. So it'll be negative x cubed minus negative x plus 1. Negative x cubed plus x plus 1, not even. Does not equal much, marginal, so that means it's negative x cubed plus x plus 1. So x cubed minus x minus 1 is not odd, so then neither. So all you gotta do is, for this one, number 12, how to determine a function. So it tells you right here. So you just determine the function by these formulas. Symmetrical can be folded into f of x. It's odd, you gotta flip over it's the a over m by 10. Also, for neither, you said not or even or odd, or f of x minus f of x. So each one has different formulas to use, and then here are some of the examples to use when you're finding even or odd or neither. So that's a pretty good example to use. So for number 13, it says explain how the zeros and multiplicity are connected. Sketch one example. Elaborate using one example. You want to show the real time steps as you solve the problem. Explain as you solve the problem. That's number 13. Number 13, all I did was explain the zeros, so also known as the roots, and solutions are round by factoring an equation and equality then to 0. So I'll put an example. So the example would be f over x equals x cubed minus x minus 3, and x plus 3 is cubed up to the 5th. So x squared equals 2 equals 0. Also x equals to 3, and then x equals to 3. So the multiplicity is how many times a particular number is a 0 for a polynomial. The above example, the 0, 3 should have a multiplicity of 1. Negative 3 would have 3. So the example would be this one also. Since equal to x minus 1 is squared in a degree. So all I did was graph it. So number 12, it says how to determine, no, number 13. It says how to zero the and multiplicity connect. So this is the example that I used. And then the multiplicity would be 2, and x would be 1. So yeah, so that pretty much determines 13. Since it's explaining how 0 and the multiplicity are connected. So they're connected to the number how many times. So 0 says the roots and solutions around by factoring the equation. Multiplicity is how many times a particular number is a 0 for a polynomial. So all you gotta do is find the polynomial or the solutions for each one, and that's pretty much solves it. So that's for it for number 13.